So we say dividing fractions, which already are division. We get a little intimidated with that because we hated fractions in the first place, but then we hated dividing also, which kind of compounds on itself, right? Here's the nice thing about dividing fractions is that we don't ever actually divide fractions. We always multiply them, which is why we do multiplication first. Plus, we didn't want to get your hopes down to start out with, okay, because fractions and division stuff, which, well, it's caused people to go crazy before. So,
Already crazy.
well, yeah, I mean, if you're in a math class. In any case, let's look at this. Again, I'm going to look at this more in terms of abstractness. So before we had A, that's supposed to be an A, divided by B, multiplied by C, divided by D. But again, this is now division here, okay? Now I said we don't actually divide the fractions. Here's why. Is we can change this into multiplication. So this first fraction, A over B, I can change this operation to multiplication, but if I do that, I've got to flip this fraction here.
Oh, yeah.
So that becomes D divided by C. Well, seeing this as multiplication, since it seems like we did pretty good on that, hopefully that feels a little bit better, just seeing that all we got to do is change it to multiplication and flip the fraction. Now on this next one, using what you know about measurement, if you took one circle and divided it into thirds, how many pieces would you have?
6. Oh, no.
3, right? You took one circle and divided it into 3 parts.
Oh, yeah.
So this one, of course, would be 3 pieces. B asks for the translation 1 divided by 1/3. So 1 divided by 1/3 would be the expression. Now again, we'll look at these here in a moment to show how to change these into multiplication.
So just flip it.
But this is how that works. What would 1/2 cups divided by 2 be?
So you go half and then you go maybe a half and a half, so it'd be a 4.
Yeah, right? So you had halves, but then you divided it by 2, which means you now had 4 parts. Okay? So this one, yeah, we got the 1/2. I guess I should write that down for part B. So this one is 1/2 divided by 2. And if we took a half and divided by 2, so we shouldn't show the S there, then yeah, we'd have or end up with 1/4 of a cup.
But
Divide and simplify to lowest terms. So again, for all these ones, we're going to change these into multiplication.
so you just be 4 over 1.
So yeah, again, we keep this first one the same. And then I'm going to change the division to multiplication, but if I do that, I've got to flip this fraction. Just so you guys understand, because you may hear this vocabulary later on, flipping the fraction is called the reciprocal. Reciprocal. Now, the reason I say this is because we use this term a lot in not only 980 but 1010 if you need to take that class. So I reciprocate that fraction to get 4 over 1. Well, now I can do some straight multiplication on this. 3 times 4 divided by 5 times 1. And 3 times 4 is 12. And 5 times 1 is 5. See, there's nothing I can simplify on this one. I can't divide 12 and 5 by the same thing to get a whole value. And there's no factors that I can cross out here. So 12/5 is my final answer right there. All right, let's do this one. So again, I've got that first number. Whatever. The first number stays the same. I'm going to change this to multiplication and reciprocate this other fraction. So I got 12 over 7. So once again, I'm going to rewrite this as multiplication of the numerators, 7 times 12, and the denominators, 8 times 7. And yeah, some of you noticed the 7s will cancel out
Oh,
right there. If not, that's okay, all right? Now, if we wanted to, then we'd just be left with the 12 over 8, right? And we can see at least that both of these are even, so we should be able to divide them by 2. Yeah, I know some of you guys know you can divide them by 4, but whatever. So I got 6 over 4. And now I still have even numbers, so I'm going to start back over here so I have some space. I can divide both of these by 2 as well, because they're even. So I end up with 3 over 2. And that's as far as I can simplify that thing. So when we change this, use a bigger font here. So I got my 9/10. And again, I'm going to change this division to multiplication and reciprocate this fraction. So that gives me 5/3. So that's at 0 right there. So I've got 9 times 5, which is 45.
I don't think your homework is shown.
And then 10 times 3 is 30. Oh, in any case, so we saw that these are at least both divisible by 5 to start out with, right? So 45 divided by 5 is 9. Is it still showing?
Yeah, it's showing now.
30 divided by 5 is 6. And then we see that 9 and 6 can both be divided by 3. So we end up with, well, that's the wrong place, 3 halves. So 6, this one's set up a little different because, again, 18, we wouldn't really consider a fraction, but it is.
It'd be 18 over 1.
Yeah, we'll make that 18 over 1. Bam. So writing this as 18 over 1. Once again, we'll change this to multiplication and reciprocate the divisor,
So it'd be 18
or the second
times
number.
3.
Yep. By the way, let's just multiply them out then. 18 times 3, so let's look at that multiplication here.
27.
I got 24, 3, and 2, 5.
I still got it.
So I got 54 divided by 1 times 2 is 2. And then this can be simplified because both these are even, but it's 54 divided by 2 directly. So 54 divided by 2. 2 goes into 5 twice. That'll leave me with 1. And so I'm looking at 14. 2 goes into 14 7 times, which also is 14, leaving me with 0. So my final answer here is 27 from this division here.
Okay.
All right, so yeah, let's start this one. So again, that first number stays the same, 7/8. Now again, I'm going to change that to multiplication. Now that 14 is over 1. So I got to reciprocate that into 1 over 14. Now when we look to simplify, I'm looking at the 7 and the 14 actually right there. Because both of those are divisible by 7. So I really end up with 1 here and then a 2 there. So then I've got 1 times 1, which is 1. And then 8 times 2, which is 16. So on this one, I'm going to look at this one a little different. I'm going to use the prime factorization to show what this will end up being. All right. So I got to change that to multiplication by reciprocating this fraction. So I got 3 over 10. So if I look at this, I got 7 times 3 over 11 times 10. But 10 can be split up into 5 and 2. Now the only reason I'm doing this is to show that there are no common factors to cancel out on this. So on the top I've got 7 times 3 divided by 11 times 5 times 2. See, there's nothing common here that we can cancel out. So to find the actual answer, we're just going to multiply these straight across. 7 times 3 is 21. And 11 times 5 is 55, times 2, 110. That would be all.
I got that right then.
So decide if each question requires multiplication or division, and then we'll answer the question. 1 dose of eye drops is 1/8 ounce. How many ounces are required for 40 doses?
So the 1/8 times 40.
Yeah, so this one will be multiplication because we have 40 of these 8-ounce doses. So that is multiplication, 40 groups of 1/8 ounces. And again, we'll make that 40 over 1. So multiplying, I got 40 times 1 divided by 1 times 8, which would be 40 divided by 8. As it turns out, that's an even number. So 40 divided by 8 is 5. And to label it in ounces, that'll do it. Alright, 10 is a little different because it says we still have the same size eye drops, 1/8 ounces a dose. But it wants to know how many doses we can make from 4 ounces. So this one is division right here. So we got the 4 ounces, but we're going to divide it into eighths. So in other words, how many eighths are there in 4 ounces? So dividing this, once again, we got the 4. But we're going to change this to multiplication of 8 over 1. So yeah, we can make that 4 over 1. 4 times 8 is 32. 1 times 1 is 1. So, yeah, we just got 32 doses.